In this question, list 1 shows 4 configurations, each consisting of a pair of ideal electric dipoles. Each dipole has a dipole moment of magnitude p, oriented as marked by arrow in the figure. In all the configurations, the dipoles are fixed such that they are at a distance 2r apart along the x direction. The midpoint of the line joining the two dipoles is x. The possible resultant electric field E at x are given in list 2. Choose the option that describes the correct match between entries in list 1 to those in list 2. Well, we have to find here the electric field at the point x. Since the distance between two dipoles that is being given here is 2r, and point x is exactly at the mid of these two dipoles, so the distance of either of the dipole from point x will be equal to r itself. The one thing that we know is the dipole is being given here like this, then at a distance r, the electric field will be equal to P2 here divided by 4 pi epsilon naught r cube along the axis itself, that is the field at axial point. And at broadside point, the field happens to be opposite to the direction of the electric dipole, and its value, that we can say it as perpendicular point here, we can write it down P divided by 4 pi epsilon naught r cube, and it is opposite to the direction of the dipole moment. So considering these two equations, or we may say the final results of the electric field, we will be calculating the effective electric field in the given situation here. So for the P, point x is exactly at the middle of it, so the electric field contribution for this dipole will be along this direction, and for this one also along this direction, and the point x is at broadside point, so we shall say the field contribution due to one dipole will be P divided by 4 pi epsilon naught r cube, and the direction upward is being written as positive j, so the downward will be minus of j. This is due to one of the dipole. So the total effective field will be contributed by both of these two dipole. It will simply be 2p divided by 4 pi epsilon naught r cube in downward j direction. Fine. So clearly we can see that option 2 that is matching here, so I'll mark 2 here. For this situation, the electric field contribution by this dipole will be in downward direction, and for this one it will be in upward direction. Since both of these two magnitudes are same, so effective electric field will simply be 0. It will be matching with 1. For this case now, at this point, the electric field contribution along this direction will be equal to P divided by 4 pi epsilon naught r cube, and for this dipole, this point is at the axial point, so it will have the contribution along this direction, that will be 2p divided by 4 pi epsilon naught r cube in I direction. This will be in negative j direction. So let's see the options here. In x direction it is 2y, and in j direction it is minus of j, so this one is matching here 4. Now for this situation, this point x is at a distance r at axial point, so for this one the electric field will be along this direction. For this also the electric field will be in the same direction, so simply I will write it down as 2p plus 2p, that will be 4p divided by 4 pi epsilon naught r cube in positive x direction. Okay, looking onto the option, clearly I can see that this 5 will be matching with S. So overall we got 2, 1, 4, 5 that will be matching respectively with P, Q, R and S. Let's see the options now. 2, 1, 4, 5. Clearly we can see that option C is the correct answer for this question. Yeah, we can see that option C is the answer for this question.